Hello, and today we are talking about nutcrackers and white bark pine.
Not that kind of nutcracker, this kind.
And this is our article.
And that article.
This is our article. Okay, to start, we're going to start off with a little introduction. White bark pine is a keystone species that are mainly found in high elevation areas of western North America. There is a specific symbiotic relationship between the white bark pines and the Clark's nutcrackers. The Clark's nutcrackers specifically help to disperse the white bark pine's wingless seeds and they do this by using a sublingual pouch to move the seeds. The white bark pine and Clark's nutcrackers were chosen to be monitored by National Park Services. The reason for this is because in the past century, white bark pine survival has been declining. One cause of this is the fungal pathogen, which causes blister rust on the white bark pine.
So now we have some methods of how they did these studies. So first they did some tree surveys. So the tree surveys were where 2 to 7 randomly located sections of about 0.04 hectares over multiple years were surveyed in multiple different parks. So each of the parks that were surveyed were studied for about 4 to 5 years, and overall the entirety of the study went from 2004 to 2016. So in that study, they identified different trees and then measured their diameter at breast height, and then examined all of the trees for status, female cones, crown kill, cankers, and any animal damage that could have been done. Then they did avian surveys, which was a multi-species bird count at high elevation sampling areas in 6 different panels. So each of those 6 panels was looked at for about a year long, and each year the panels changed. But the first panel number 1, was always done. So for example, the first year, panel 1 and panel 2 were done, and then the second year, panel 1 and panel 3, and so on. So they always did these surveys later in the year to match with nesting points. Then they also had point count stations, which were where trained observers counted nutcracker sightings and accounted for noise level from the birds and presence of cover that the birds could use. Then they did a little analysis, which is where they modeled nutcracker density in a hierarchical model called the poison model. This is where they modeled avian abundance and their detection. So this model showed the nutcracker dependence on white bark and also included the white bark seed production. So one of the outcomes, or rather what these methods showed, is that the white bark seed proxies versus the foxtail seed proxies, which is one of the trees that were supposedly taking over white bark area. Then they observed the link between the birds and seed amounts produced by the trees.
So our first graph is showing some of the distributions of white bark pines and nutcrackers in Yosemite National Park. The part A of the very top graph shows the estimated density of nutcracker birds in different survey areas. Part B is depicting the results they found about the area occupied by white bark trees in each section surveyed, which is called a basal area. Part C is the average number of trees with male and female pine cones present. The yellow and orange color in the background of each map represents the white bark trees present. And the darker shade of circles or triangles, the more concentrated the population of nutcracker birds or pine trees, which directly correlates typically to the elevation and presence of white bark trees in a positive way. The basal area and cone tree maps look very similar because the location of the triangles of the shadings, they're connected significantly, which makes sense because where there are white bark pine trees, there should be white bark pine cones. And then our next one is a table. This table organizes all of the mean and standard deviation data that was collected from running software simulations based on the actual data they collected in the field at Mount Rainier National Park. There's other tables as well that put all the data for temporal simulations for the Northern Cascades National Park as well, and I think tables as well for the other parks that they did. But we're just going to look at this one. From my understanding, year H1 that symbol, is part of the program that is measuring the density of nutcracker birds over the course of time, and it's independent from the white bark trees and how the white bark trees change over time. All of the H2 variables are showing how over time the nutcracker density could have been influenced by white bark trees, and the white bark tree variables that are tested were for canker sores, rust disease, which is a fungal infection, and crown kill, the canopy mortality. For example, if we look at the nutcracker HA row, which is the top row, and rust trees H2, the mean value is 0.014 with a standard deviation of 0.004, which is the same mean and standard deviation for all nutcrackers in that row. So like that whole column has the same data except for under the column crown kill H2, which has a mean of 0.13. We could interpret that there is likely to be less nutcrackers per hectare found in white bark pine trees with thin or little canopy. Additionally, the article mentions that as time went on, the density of nutcrackers seemed to decrease, which is indicated by all the negative numbers in the BN2 parentheses T and BW1 year, which are coefficients and covariants that their simulation created. And that's specifically just for the Mount Rainier. Other parks had slightly different results.
So, in conclusion, the study found that nutcrackers shift habitats based on resource availability. They also found that the decline of nutcrackers in Mount Rainier National Park was not tied to the crown kill of white bark trees. However, they also wanted to conduct a few more annual tree surveys on this to discover what the connection is. Another thing they found is that nutcracker dynamics in Mount Rainier might suggest a shift in foraging behavior rather than an actual population decline. And then in order to further discussion and study on this topic, they would like to track birds and do large-scale surveys that could give more evidence on these behaviors. So the article mentioned 3 different challenges to this study. First, they need to consider that nutcrackers use a number of resources. So when you're conducting a study, it's good to determine how those resources are distributed and how a researcher would monitor this in the field. Another challenge is that they need to understand the seasonal variation of resource use and match the dates of nutcracker monitoring to the dates of resource use. And then finally, another challenge was that the data on comb production in white bark trees is virtually non-existent, so that just makes it difficult to assess if comb production is tied to nutcracker declines.
So we have some follow-up questions, which include, the first one we have is, what other tree species do nutcrackers use? So the study didn't specifically focus on this, so this could be another idea for a separate study, but generally they had a few listed, and we would hope that they don't just utilize the white bark pine. And then additionally, we're curious about which tree is visited most by nutcrackers. So if you looked into other species that they use, which one might be the most visited? Is it the white bark pine or is it some others? And then we have, if nutcracker birds went extinct, what would be the potential side effects on the white bark trees? So if we lost all the nutcracker birds and they were no longer distributing seeds for the white bark, would another species come up? Would the white bark trees die? Or would there just be a significant decline? And see what potential happens there. And then our last question for follow-up is, if there was a drastic decline in white bark trees, how would the other plants in the ecosystem be affected? So this study was specifically focusing on the relationship between nutcracker birds and the white bark pine trees, but what if we zoomed out a little more to the entire ecosystem of deciduous forests like this, or evergreen forests, and how the white bark trees play a key role in that, and how other plants, shrub layer, other evergreen trees play a role. And then some improvements are conduct the field data collection during the same year as all the parks. So they did the study over multiple years, studying different parks at different times. what if we all did it just in the same year, if you had enough resources to have people all over at the same time collecting data, or decrease the amount of variables being assessed. So rather than having like the elevation, the different years, and the amount of species, try just picking one of those variables and focusing on that. And here are our resources.